The goal of this study is to determine the utility of using game data collected during gameplay to identify adolescents with unhealthy substance use who may then benefit from being connected to care. If we successfully develop a model, future work will test if this can potentially be used as a screener in clinical settings. When anyone plays a game, their performance in the game can be influenced by cognitive processes such as working memory, processing speed, and inhibitory control, which are also impacted by substance use. Our study has two main phases. In phase one, the focus of this talk, we developed a machine learning model using in-game data to predict unhealthy substance use among adolescents. In phase two, we will test if our model correlates with cognitive processes impacted by substance use. For phase one, we used data from a prior study using a video game designed to prevent high-risk behaviors such as risky sexual behaviors and substance use. In that study, data on unhealthy substance use and efficacy, that is, confidence in one's ability to refuse substances, were collected at baseline using validated scales. Responses from these scales were used to compute binary outcomes for unhealthy substance use and self-efficacy. Data from 160 participants who played the game were used in analysis. Next, we identified 285 relevant in-game metrics. We performed unsupervised feature selection, where we normalized and filtered features with high correlation and low variance, resulting in a final list of 239 features for training our machine learning models. We built 6 binary classification models which were trained to predict unhealthy substance use and self-efficacy to refuse substances. We split the sample into a 70-30 trained test set for model evaluation. To assess the models and identify best-fitting models, we used 5-fold cross-validation to calculate AUC code values, sensitivity, and specificity. The best-fitting model for self-efficacy was logistic regression with an AUC of 0.63. The best performing model for unhealthy substance use was the neural networks model with an AUC of 0.61. Limitations include the use of a video game designed to change behavior, and so it is possible that with repeated use, the ability of the model to predict unhealthy substance use may change. Similarly, we assume that gameplay performances rely on brain processes that the game may improve. We also handcrafted features used in the model, and so may have missed other features that may be useful in prediction had we used all the in-game data. Despite these limitations, and although these are very preliminary and further validation is needed, initial results suggest that we can use in-game performance to predict unhealthy substance use, and therefore, game-based screening may be an alternative to screening strategies that require already limited provider time in clinical settings. As such, they could be used to help identify adolescents with unhealthy substance use, allowing for timely interventions.